Hello everyone, welcome back to this week's devlog for Clustercraft, Strong Compute's 3D Compute Manager. We've got some really cool features to show you today related to how we're going to visualize how powerful GPUs are in relation to each other. So far, all of them have just been this standard size. Up until this point, they've all been the same proportions, and it wouldn't really be clear how powerful one is compared to another.
Yeah, I've been waiting for this for a long time. I'm very excited about this. One of the really important principles of the interface is you should know what things are by looking at it, not by reading numbers off a chart. So is your GPU more powerful? Can it hold more stuff? Well, let's find out. Let's do a little visual tour.
So we're going to start scrolling up first.
Yeah.
And as we go up, these ones, as we can see, are H100s. And if we go upwards, we're going to find some A100s, which are comparatively thinner. Now, they're about as thick, which the horizontal axis is indicative of processing power.
No, the horizontal axis
is VRAM.
Is
correct.
VRAM.
Yeah,
so how wide is your bucket? What can fit in your bucket? That's determined by how wide it is.
Let's just double check.
Based in our universe.
Yep, that would be correct.
Can your job pass through the gap?
See, the VRAM here total is 640 gigabits.
Gigabytes per node, or gigabytes.
This is about the same.
Per node. Yeah, so you're getting the same because you've got 8 by 80.
That's correct.
So this is a A100 80 gig, so it's got the same VRAM as the H100.
There you go.
So the GPUs are just as wide. However, they are less performant, so they're not as tall, or whatever axis we want to call that, looking down at it. But pretty soon you'll see why we're calling it tall. And that shows that it doesn't have as much performance, and so it's going to do the processing slower. And we've tried to index this based on FP16, and we know there's all kinds of chips have sparsity and all that. Maybe in future we'll let you kind of do it based on that, where if sparsity is available, maybe you get some more performance, or if you're doing it in 4 or whatever, you're going to get some more performance if the chip supports it. Otherwise it'll have to fall back to something else. But right now we just said, look, FP16, that's sort of a common denominator. Like, all chips can do FP16, and the better chips do it better. So that's going to be how we kind of show up relative performance.
Yeah, I think just looking at all the different types that I've cycled through in my testing, it seems to be pretty well indicative of how strong they are relative to each other. So FP16 works very well for this. We're scrolling up now to V100s, which are older as well. We could see less VRAM and even less powerful at FP16. So they're getting nice and little tiny ones. And if we go right up here to P100s, you can barely notice them. They are sort of getting outdated, as I understand.
Which is kind of funny that, the actual GPUs that drove the whole deep learning revolution were even weaker than these. So it just shows you how far we've come.
Yeah, the standard size, as I understand it, is H100, which if you told someone back in the era when the P100 was the standard that this is how much bigger and better they are this quickly into the development of AI training, it would blow their minds. So this is I think we can get smaller than this, but at that point you wouldn't be able to really see it, and it would be irrelevant. So that's all good. Now we got a sneak peek before when the camera moved out, but we're going to move past the H100 to these are B200s. So you can see a lot more VRAM, and I think these are more powerful GPUs, just slightly taller. So yeah, these ones you can very clearly see, okay, they're nice and thick. They can store a lot more. My data sets can be a lot larger with the same number of nodes. And as we come even further down, we have our NVL72s. So these are a lot bigger than even the B200s. They're in double columns because it's how they're arranged in real life. And there's 72 per node in this example. You can see they are a lot bigger than even the H100s that are the standard at the moment. And you could just see with your eyes how much more powerful each node is.
Yeah. Absolutely.
It's really, really cool.
So with this in mind, it's challenging to kind of see it all in 2D. We're kind of running out of space here.
Yeah,
so what we've done is we've now got a little toggle you can turn on.
Yeah, we've got a lot of settings here
and you can pop them up. Now, this is going to make it easier to see bigger clusters and work with bigger clusters, because obviously, like, you know, if you're buying NVL72s, look, some people are buying a couple of NVL72s, but a lot of people are buying thousands or tens of thousands. And so we really need a way to kind of represent them, that we're going to be able to fit them all in a lot easier. There's also the ability to, you know, if you don't like these dynamic GPU sizing, if you're like, look, I'm only working with, you know, H100s or GB200s or something, you can just turn it off, and just everything will go back to being a single, you know, H100 reference size. But I think, you know, if you're working with an organization that's got different GPU types in it, you're probably going to want to like actually recognize they've got different levels of performance, because it also correlates pretty well with their cost. And so, you know, you want to care about the bigger resources more, because they're costing you more money, and you really want to focus on saturating them. And you're probably fine to pretty much ignore the, you know, the legacy stuff, because it's just not big enough to care about. Relatively speaking, of course, you know, whatever the largest GPU you have, that's the one where you're probably going to be caring most about the cost.
Yeah, absolutely. This is going to help immensely with just large visualization of all of your data, especially when you have a bunch of different resources in your infrastructure.
Now, we've got this supported for NVIDIA GPU types, but we're also bringing in the data for other vendors now. So if you go to make a new cluster,
let's take a look at, I'm going to lay it flat. Let's take a look at all of the options we have here. These are, we can see that on the recording.
So the top of the list is the NVIDIA GPUs.
Yep.
And then after that, we get into the MI series from AMD.
Yep. We've got a couple more NVIDIA ones here, and then these last two are Intel.
And then we're also going to be putting in the Cerebras and a few more vendors as well. So we'll look at maybe how to group these a bit more by vendor or something, and by era. But that is, we want to give you folks the options. If you're using different GPU types, you want to be able to see how they go.
Yeah.
And so I'm really happy to see this.
Okay, so the next thing we've been working on, and we announced it in the previous devlog, is the system of LODs. So we were noticing that at very large numbers of infrastructure, the computer would begin to throttle because it would begin to try and render lots and lots and lots of infrastructure, and it was beginning to slow the system down. So we decided to work on a system that would show off large amounts of infrastructure simply, so that at a glance you can quickly pass how much infrastructure you've got, while also maintaining the computer's performance. So to do that, we have a work in progress version at the moment. We have low LOD systems. So if we zoom out a little bit, we can see that the nodes at the moment are clustering into smaller boxes, which saves quite a bit of memory because it's not rendering all the GPUs, but it is still showing the same amount of data as if you were rendering the nodes at full quality.
And we have about 3 million GPUs worth of nodes out here.
GPUs, yeah. So it will be possible. So Ethan has built a system where when you zoom in, you will actually go and see the GPUs again. Right now, we're just integrating that capability. That should come out shortly. Yep. But one of the questions we had was how many GPUs actually matters. And so we did a little bit of math, and we're like, how many GPUs are there in the world? How many will there be in the world? So by 2030, there's a projection of about 150 gigawatts of AI data centers. You're looking at, average numbers around a kilowatt per GPU. So that means about 150 million GPUs. So we want a way in a single browser, in a single interface, to be able to see 150 million GPUs. Now, Ethan assures me that he's tested up to 30 million GPUs.
30 million does work.
And we've hit still around 60 frames a second on a M1 MacBook for 30 million GPUs, which is pretty awesome. And so we're only 5-fold away from hitting all the GPUs in the world in a single interface.
That's going to be really, really cool.
And when you zoom in, you'll be able to see them, and we'll be able to load data for them, and they'll be able to tell you, what they're doing and how warm they are and all the rest of it.
Yeah. So
we'll be able to break them up into regions, so you'll actually not just see like a pile of 150 million GPUs. They will be spaced around the world, or at least into groups according to, which provider and where in the world they are. We're certainly pushing the limits of the graphics card here.
Yeah.
And we'll continue to refine that so we don't have that sort of fizzing.
When you have this much stuff, the GPU starts to be like, confused on what it needs to show really, really far away. So you get this kind of flickering. This can kind of get solved as you make these boxes larger, which is part of the dynamic system that's being integrated right now.
Yes.
So yeah, we might have multiple LOD.
Yeah. So the big challenge with rendering this much stuff isn't necessarily the rendering power, because you're able to instance a lot of meshes pretty well. It becomes a problem of memory, because you need to store positional data, positional matrices for every single mesh that you've got. And also you can't really, unless you have a giga PC, which is kind of what we're going to be using to show this off to you, unless you got that much horsepower.
To load our website, you need to spend $10,000 on your computer. I think that's the minimum to use the website. Yeah.
We're trying to make the cost of entry as small as possible by rendering as much as possible.
But if you want to show 30 million GPUs, you're going to need a pretty beefy rig.
Yeah.
That's the point. If you're going to want to load 30 million GPUs worth of data from an API, that kind of thing is going to be extremely slow and extremely slow to allocate. So the way we're going to do it is, once you zoom in and these turn into smaller nodes and you click on them, they will pull the data from the API as you load them up. So once you go in and you're like able to see the higher level of detail, I intend to try and get the browser to pull that stuff dynamically, and then it will go and show, okay, this is the real temperature of your stuff right now. It's not going to pull it all right when you load it, because if you do, then it's going to take like a long time for all that data to come through the internet.
That's right. And then it's going to
update.
And then it's going to tank
and
the
be out of
performance
date.
of the computer, because all that's going to have to be stored frame by frame. So we're going to be using a lot of smoke and mirrors to make it look like you're rendering millions and millions and millions of high-level nodes, only showing off the ones that you're directly looking at, and keeping the performance cost performant at long distances away.
It's still going to be a struggle to render every single GPU in existence and every GPU that will exist. But if you've got the horsepower for that, it will look really, really cool.
We will. We will try.
This is exciting stuff, guys.
All
right.
Awesome.
I guess I've got one more thing to show off. So one of the things we intend to do with the sandbox of the cluster manager is show off a bunch of real life data centers that are being produced and coming into commission, and show you the scale of them in our interface. And to do that, we've created some cinematic modes. We've shown off sort of the cinematic camera in a previous week, but we've added an interface for adding sort of a news style lower thirds. So if we wanted to give a title like brand new data center is crazy powerful, and everyone's looking forward to what can be produced with it. Obviously, I'm not the copywriter. You can choose the position on the top or the bottom. You can say if you want it to loop, and you can specify a country. So if I was to say, United States of America, when you hit start cinematic, now we've got this bit on the top that will say all the information we put in. We've got this globe showcasing where in the world it is, and we've got this really cool flyover that we can record and put on social media sites. So that's really, really sick. This globe is actually, you can kind of rotate it if you want. It's not like you're going to be doing this if you're recording a news site, but it shows you that this is like a 3D globe, and we've highlighted the region that you've entered in. If you were to put in like another region, like if we put in Australia, you could change the position, and it just straight up works. This is really, really cool, and I'm looking forward to the kind of stuff that we're able to showcase with it.
Love it.
Awesome. So that's what we have for you this week. Tune in future weeks when that level of detail stuff is ready, and we can render a buttload of infrastructure.
All the GPUs in the world.
All the GPUs in the world.
That's our motto at the moment. It's on our whiteboard. All the GPUs in the world is what we're claiming.
Sweet. All right. See you next time.
All good. See you soon.